Hi, so for today we're going to talk about the integrals yielding inverse trigonometric functions, and for this video we're going to solve some problems. I think 10 problems involving integrals that will yield to an inverse trigonometric function. So if the integrand has this form such as the 1, second, and third formula, okay, so it would yield to an inverse trigonometric function. So the first one, we have the integral of du all over square root of a squared minus u squared, where a is any constant, that would yield to an arc sine of the u all over a plus c. For the second formula, we have the integral of du all over a squared plus u squared equals 1 over a. The same definition for the a, it's constant, arctan of u all over a plus c. And if we have this form of integrand in our integral, so we have integral of du all over u multiplied by the square root of u squared minus a squared, where a again is any constant, that is 1 over a arc secant of u all over a plus c. So in order for us to understand that, let's solve some problems. I think we have many problems here. So for the first one, we have the basic. We have the integral of dx all over x squared plus 9. So how do we integrate that? Okay, so we can rewrite the integral as the integral of dx all over x squared, okay, plus, okay, 3 squared. Okay, so this in turns, okay, this will be our u, this will be our a. Okay, our value of u here is x. Okay, the value of our a here is 3, not the 9, because according to our formula, this 9 is in terms of squared, u squared, or a squared, I mean a squared. Okay, a squared. So we have to have the integral of this denominator resembles the integral that would yield an arctan because of the a squared plus u squared. This is u squared plus a squared. Doesn't matter if they switch position, since that is it's okay. Okay, so we have a squared plus u squared. So our formula would be 1 over a. Okay, 1 over a, which is 3. Then we have arctan of u over a. The value of our u is x, okay, the x all over the a, okay, which is 3 plus c. So this would be our simple answer for our simple problem for number 1. So how about for number 2? We have the integral of dx all over the square root of 25 minus 16x squared. So we can rewrite this first as this. So we have 5 squared, that is equivalent to 25, minus we have 4x squared. Okay, so the value of our a here, which is the constant, is 5. The value of our u here is 4x. Okay, so now what are we going to do is we simply get the derivative. Okay, so we will be using u substitution here. Okay, because as we can see, we have a u of value of 4x. Get the derivative of u with respect to x, that is 4dx. Okay, and then we're going to get dx, that would be du all over 4, so that we can substitute it here. Okay, the dx. So what will happen is that we have the integral, okay, of du all over 4. That is dx. We use u substitution. All over, we have the square root of d, okay, that is a squared. That is the value of our a, 5, minus we have du squared. U is equal to 4x, so that we have a u here. So we can factor out 1/4 outside of the integral sign. We have du all over square root of a squared minus u squared, which is actually an integral yielding arc sine. So we have 1/4 multiplied by the integral of this, and the integral of that would be arc sine, okay, of u all over a plus c. Okay, so this is equivalent to 1/4. Distribute the 1/4. 1/4 times arc sine would be arc sine of u all over a plus 1/4 times constant is still plus c. But remember that our u is equal to 4x and our a is equal to 5. So we have to back substitute that. So we have 1/4 arc sine. We have 1/4 arc sine of u, which is 4x all over 5 plus c. So this should be our answer for the second problem. Okay, so number 3. So for number 3, we have the integral of dx all over 4x squared plus 9. The very first step again is to rewrite this as the integral of dx all over 2x squared plus 3 squared, wherein this will be our value of u and this would be our value of a. Okay, and a equals 3 and u equals 2x. So we will still use the u substitution here. So we have the derivative of u with respect to x is 2 dx. And we have du all over 2 equals to dx. So that we can now substitute it. So upon substituting it, we have du all over 2 all over, okay? So we have u squared plus a squared. So we can factor out 1/2, okay? And then we have du all over u squared plus a squared, in which we know that this would be an arctan again. So we have 1/2, okay? So we have 1 over a arctan of u over a plus c. So we distribute 1/2. So we have 1/2 times the 1a arctan of u over a. So we have u all over a plus c now. Okay. So again, a is equal to 1/2. We have 1 over 3. We have arctan. We have u equals 2x all over 3 plus c. So simplifying, we have 1 over 6 arctan of 2x all over 3 plus c. And this should be our answer for this problem. Okay? So for number 4, let's try to solve another problem. For number 4, we have the integral of dx all over, we have x square root of 4x squared, okay, minus 9. So we can rewrite this as the integral of dx all over x. We have the square root, okay, of 2x squared minus 3 squared, which in turn, this would be still our value of u and this would be our a. So if we have u equals 2x, the derivative of u with respect to x would be 2 dx. Getting dx, we have du all over 2. We have dx here. And the value, of course, of our a should be 3. Okay? So what are we going to do is we simply substitute. We need also to get x. Okay? So we will be getting x in terms of u also before we can perform the substitution. So from this formula, the x will become u over 2 equals x. So we are now ready for substitution. So we have dx is equal to du all over 2, which is this. All over, we have x. Our x is equal to u over 2. Okay? Square root of what? We have u squared minus a squared. So as you can see, these 2's will cancel. Okay? So that we are left with the integral of du all over u square root of u squared minus a squared, which is actually the formula for the integral yielding arcsecant. So we have 1 over a arcsecant, okay, arcsecant of u all over a plus c. We need to back substitute it. So the value of a is 3. 1/3. We have arcsecant of the u, which is 2x all over a, which is 3, plus c. So this should be our answer for problem number 3. What I mean is number 4. Okay. So number 5, for number 5, we have the integral of x squared dx all over square root of 1 minus x raised to 6. So again, we have x squared dx square root of 1 squared. Okay. By laws of exponent, this should be x cubed squared. Okay. So x cubed squared is equal to x raised to 6. Okay. So that our x or our u would be x cubed and our a would be 1. Okay? So by u substitution, again, we need to differentiate u. We have x cubed, we have du, we have 3x squared dx. I would like to get here the x squared dx because as you can see, x squared dx is present here. So we have du all over 3 equals x squared dx. So that I'll be having x squared dx is equal to du all over 3. All over we have square root of a squared minus u squared. Okay? And again, this will yield to what? An arc sine. Okay? So I can factor out 1/3 first so that you would see the form. Okay, du all over square root of a squared minus u squared. And this will result to an arc sine, 1/3 arc sine of the u all over a plus c. Okay, so we have 1/3. We have to back substitute it. So we have u equals x cubed all over a, which is 1, plus c. Or simply, we have 1/3 arc sine of x cubed plus c. Okay, this is arc sine. Okay, for number 6, let's try to solve the integral of x dx all over, we have x raised to 4 plus 3. Okay, so how do we integrate this? So that would be the integral of x dx all over, we have x squared squared plus, of course, we should have get the square root of 3 squared, so that if we squared square root of 3, that would still be equal to 3. Okay? So this would be our a, or our u, I mean, x squared, and a would be equal to square root of 3. So our u will be x squared. Get the derivative. We have 2x dx. Okay, x dx is present in the numerator, so I would have to leave x dx on the other side. So we have du all over 2, and we have x dx here. Of course, our a equals square root of 3. So perform now the substitution. So we have x dx, which is du all over 2. All over, we have u squared plus a squared. So I can factor out 1/2 outside of the integral sign. So that this would be like this. U squared plus a squared, or a squared plus u squared, doesn't matter. So this would yield to an arctan, we know. So we have 1/2 all over multiplied by quantity 1 over a, arctan of u all over a, okay, plus c. So but a is equal to what? Square root of 3, so 1 over square root of 3, arctan. So u is equal to x squared all over square root of 3 also, plus c. So if you multiply that, 1 over 2 square root of 3 arctan, we have x squared all over square root of 3 plus c. We need to simplify. Okay, that. So if we simplify that by multiplying here, square root of 3 all over square root of 3, rationalizing, and here also. So if we multiply that, so let me just rewrite so that you would understand. Okay, x squared all over square root of 3. So we also would want to rationalize this. So what will happen is that we have square root of 3 all over square root of 3 times square root of 3 is 3. So 2 times 3 would be 6. Arctan of, we have square root of 3 x squared all over 3 plus c. Okay? So, or square x squared square root of 3 over 3. That is still the same. Okay, so we have the final answer of square root of 3 all over 6 arctan of square root of 3 x squared all over 3 plus c. Okay, for number 7. So we have for number 7, the integral of dx all over x square root of x raised to 4 minus 1. So how do we get the integral of that? Okay, so rewrite that at integral of dx all over square root of x squared minus 1. Okay, so that this would be our u, x squared, and this would be our a. Okay, so as usual, our a would be 1. Okay, so u substitution again. So we have u equals x squared. We have du 2x dx. So we have du all over 2, okay, is equal to x dx. Okay. Now, the problem with this is I don't have x dx. So, I would simply multiply this whole equation dx all over x square root of x squared minus 1 squared by simply x over x. Okay? So, multiplying it by x over x is still valid as long as you multiply it in the numerator and the denominator because x over x is still equal to 1. So, simply, this would become x, the integral of x dx all over, we have x squared over the square root, okay, multiplied by the square root of the x squared minus 1 squared. Okay? So we have x dx all over x squared here. Of which, if we are going to uh, simplify, or I mean, you substitute it, so x dx will now be equal to du all over 2 all over, we have x squared here, and x squared is equal to u. Square root of, we have u squared, okay, minus a squared. So we can factor out 1/2 outside of the integral sign so that we have du all over u multiplied by u squared minus a squared, of which this is arcsecant. Okay? So we have now 1/2 multiplied by 1 over a arcsecant of u all over a plus c. And that would be 1/2. 1 over a, okay, is still 1 over 1. Arcsecant, still 1. Arcsecant of u, our u is x squared, our a is 1 plus c. So our final answer would be 1/2 arcsecant of x squared plus c. So this would be our final answer for this integral. So for number 8, let's try number 8. Number 8, the integral of dx all over, we have e raised to x plus e raised to negative x. Okay. So the very first thing we're going to do here is that simply we cannot do the technique that we are doing a while ago because this term both contains x, but we have to eliminate x. So by simplifying, we have integral of d all of x all over e raised to x plus e raised to negative x could be rewritten as 1 over e raised to x by loss of exponent. So I would rewrite it as e raised to x. Okay? So, and I will perform what? Addition of this. Okay? So, simply, if we add this, multiply this one. So, if we multiply e raised to x, multiply by e raised to x, that is e raised to 2x by loss of exponents. So, we have e raised to 2x plus 1 and copy the denominator. Okay? E raised to x. So that, if we rearrange this, okay, if we rearrange this, this would be dx, okay? Get the reciprocal of this and multiply it with the dx. So this would be, get the reciprocal of this, the denominator, okay? Change the it to multiplication. That's how we change fractions, okay? So what will happen? We have e raised to x all over e raised to 2x plus 1. So that we have integral of e raised to dx, e raised to x dx all over e raised to 2x plus 1. And now, we can perform what we are doing here. So, we have the integral of e raised to x dx all over, okay, all over e raised to x squared, okay, plus 1 squared. Okay, wherein e raised to x would be our u and 1 would be our a. So, our u is e raised to x. Derivative of u with respect to x is e raised to x dx. Okay? And we can easily substitute it. So we have e raised to x dx equals, we have du, okay? We have du all over, we have u squared plus a squared. Let me just rewrite the, yeah. Okay? U squared over a squared. So this is in form of arctan. So 1 over a arctan of u all over a plus c. Back substitute the values of a and u. So we have 1 over a. Let me just rewrite this on the side. So 1 over a would be 1 over 1. Arctan of u all over a. Our u is e raised to x over 1 plus c. Or in other words, our final answer would be arctan of, of e raised to x plus c. It's very simple. That is our final answer. Okay, let's get to number 9. So for our question number 9, we have secant of x tangent of x dx all over 9 plus 4 secant squared x. So what we can do here is, again, the technique that we are doing from our previous example. Okay, we can rewrite the denominator as 3 squared plus 2 secant x squared. So this would be our value of a and this would be our value of u. So our u would be 2 secant of x. Okay? Then the derivative of that, 2 secant of x, would be 2 secant of x tangent x. Of course, okay, dx. Okay? And then, getting in the numerator, we have secant of x tangent x dx, so we would leave that on the other side. So we have du all over 2 secant of x tangent x dx, which is readily available on the numerator. Okay? So we simplify. Secant of x tangent of x dx is equal to, we have du all over 2 all over, so this would be our a squared, and then we have u squared. So we can factor out 1/2 outside of the integral sign. We have du all over a squared plus u squared, of which we know this form is in terms of arctan. 1 over a arctan of u all over a u all over a plus c. So we have 1 half, back substitute the value of a, that's 1 over 3. We have arctan of u. What's the value of u? That's 2 secant of x all over 3, which is our a, plus c. So simplifying, we have 1 over 6 arctan of 2 secant of x all over 3 plus c. Okay? And this should be our answer for problem number 9. Okay, for the last item that we have for today's video, we have number 10. We have the integral of x plus 3 dx all over square root of 1 minus x squared. Okay? So in this case, what are we going to do is rewrite the integral as x dx, since this is addition, all over square root of 1 minus x squared plus integral of 3 dx all over of square root of 1 minus x squared. Okay, sum of integrals. So this one, we can use u substitution here. So we have 1 minus x squared. Our du would be negative 2x dx. So x dx is present on the numerator. So we can have du all over negative 2, which is equal to x dx. So this is problem solved. How about in this one? So we can rewrite this also as 1 squared and x squared. So the value of our u here would be x. Okay. And then the value of our a here is 1. Okay. So that we can simplify it. So what will happen? We have x dx. X dx here would be du all over negative 2 all over. We have the square root of u. Okay, this is u. Okay, plus I can factor out 3 outside of the integral sign. Integral of, the derivative of u is du equals dx, simply dx. So we can simplify du all over, we have square root of a squared minus u squared. So this resembles arc sine. So we have negative 1 half integral of du all over the square root of u plus we have 3, okay, arc sine of u all over a plus c. So we can integrate this, okay. So this would be, we know that this is raised to 1 half. If I'm going to uh, put this on the numerator, I'll be negating the sign, okay, or the exponent. So that would be u raised to negative 1 half du plus 3 arc sine of u all over a plus c. So integrate this by power rule. So we have negative 1 half plus 1 would be u raised to 1 half all over 1 half, okay, plus 3 arc sine of u all over a plus c. So this, as you can see, 1 half, okay, 1 half cancel. Okay, the 2 there will cancel because 1 half divided by 1 half would cancel. So we have 2, okay, here. If we, this should cancel the 2. Okay, so we have negative u raised to 1 half plus 3 arc sine, oops. So this would be arc sine of u all over a plus c. So the u here, okay, take note, this is our u, value of u, negative square root because of 1 half, 1 minus x squared plus 3 arc sine, backstab the meaning of u here. Okay, what's the meaning of u? What's our substitution for u is x all over a, which is 1. So simply this becomes x, okay, plus c. And that should be our answer for this problem of integrals involving or yielding inverse trigonometric functions. So if you find this video helpful, please don't forget to subscribe to my channel for more videos or tutorials all about mathematics and engineering subjects. So thank you so much for listening. God bless. This is again Engineer Abat.